Hello friends, in the last video we discussed about combination and decomposition reaction. So in this video we will start with displacement reaction. Displacement reaction is very much simple reaction. In this reaction, active metal displaces the lower active metal from its solution. Here in this case, iron is more active, copper is lesser active. So iron is displacing copper from its own solution and forms a new solution. Okay, for easy understanding, we have taken copper sulfate solution where we have taken two iron nails as positive electrode and negative electrode. So when electricity is passed through copper sulfate solution, copper sulfate breaks down to Cu2 plus positive ion and SO4 2 minus negative ion, and after dissolution the iron nail forms Fe2 plus, which is also a positive ion or cation. As I have already told you that Fe2 plus is more active than the Cu2 plus, so it has the ability to displace Cu2 plus, and it will displace Cu2 plus and reacts with the SO4 2 minus, which was already present, and forms a new solution FeSO4. But Cu cannot displace Fe, that means copper cannot displace Fe because Cu is lesser active. That's why this reverse reaction, the reverse reaction is not possible. Okay, after the reaction, what is the result? We all know that the copper sulfate solution color is blue. So after reaction, there is no more copper sulfate. Here is the formation of new solution, that is FeSO4. So the copper sulfate solution's blue color fades because there is no copper sulfate solution. That's why the blue color of the solution fades. And what will happen to this copper? This copper, because it is positive ion, it will attach to the negative electrode. So here is the negative electrode, the iron nail. So this copper will deposit over the iron surface. The result will be the iron nail becomes brownish. Why this brown color is due to the deposition of copper. So it is very much simple. Other example is this one. Zinc is more active than copper. So zinc has the ability to displace copper from its solution and forms a new solution, zinc sulfate, displacing the copper. So after displacement reaction, we can proceed next. The next reaction is double displacement reaction. It is somewhat similar to the previous displacement reaction. Here double exchange occurs. That means, for example, we have taken this reaction where sodium sulfate, which is aqueous solution, barium chloride, which is also aqueous solution, when these two solutions are mixed, we get the precipitate formation of barium sulfate. Remember, precipitate formation of barium sulfate and sodium chloride. Okay, precipitate is nothing but when we get some kind of deposition beneath the solution or at the bottom of the beaker. So this is called as PPT or precipitate. Okay, some kind of precipitate is observed during this reaction. So here we can see that sodium, which is metal part of this solution, displaces the barium metal part of this solution, and reversely barium is also displaces sodium in the second phase. So becoming the sodium sulfate becomes barium sulfate and barium chloride becomes sodium sulfate. So sodium and barium both has replaced each other. So exchange of ions between the reactants has occurred here. We have the next reaction, which is oxidation and reduction. Okay, let us first take oxidation. Oxidation is addition of oxygen. Remember, addition of oxygen or removal of hydrogen. One of them if occurring, then oxidation is occurring. And reduction is addition of hydrogen and removal of hydrogen. Just opposite. Addition of oxygen, oxidation. Addition of hydrogen, oxidation. Removal of hydrogen, oxidation. Removal of oxygen, reduction. Okay. For example, oxidation reaction example is this one. Here copper is added with oxygen, so addition of oxygen, so copper has been oxidized. Mind the statement, copper is oxidized to cuprous oxide. We will state like this, copper is oxidized to cuprous oxide in presence of heat. So here is an example of reduction. Cuprous oxide, from cuprous oxide oxygen has been removed, so removal of oxygen becomes reduction. So we can say here cuprous oxide has been reduced to copper. Copper is oxidized to cuprous oxide is reduced to copper. So that's it. This reaction is occurring only in presence of heat also. And one more thing is there in this reaction is that hydrogen. What about the hydrogen? What has happened to hydrogen? The hydrogen was alone, and after the reaction we get the formation of water. That means addition of oxygen has occurred here. Addition of oxygen is oxidation. So in that case we say that hydrogen is oxidized. Cuprous oxide is reduced to copper. Hydrogen is oxidized to water. So in this reaction only, reduction has already been discussed. Oxidation is also occurring. So in a single reaction, when both oxidation and reduction occurs, that type of reaction is known as redox reaction. So I think I'm clear with this, that when in a single reaction both oxidation and reduction occurs, that type of reaction is known as redox reaction. So this is a very good example of redox reaction. Now we have the last application part, that is the applied chemistry part. So oxidation is going, oxidation, not only oxidation, both oxidation and reduction, redox type of reactions are going on inside or outside our body, also in the environment every day. So we have taken two examples which are given in the textbook. So effects of oxidation in our daily life. So first, the most studied effect is the corrosion. Corrosion means corrode. That means there is a kind of loss, damage. Now let's see how. Okay, we have many of us know about rusting of iron. It is very common phenomenon. So what happens during rusting of an iron? Actually, what is rusting? So we know that many of the items of our surrounding are made of iron, like bus, rails, etc. Many items are there which are made of iron. So when iron reacts with oxygen, from where this oxygen has come? From environment. So when iron, which was strong, solid, this S is not for strong, this S is for solid. So when this solid iron reacts with this gaseous oxygen from the environment, it forms ferric oxide. It is called as ferric oxide. Ferric oxide. It forms ferric oxide. Ferric oxide is also solid, but there is a difference. This is like a rod. You cannot bend it, you cannot break it, because it has huge strength. It is very much strong. But this one solid, though it is solid, but it is powder. It is powder. So we know that there is a huge difference between an intact rod, a strong rod, and some powder. So in this way there occurs damage to the iron items. So this phenomenon is called as corrosion, and this is nothing but addition of oxygen resulting in oxidation. Now we have the second topic, that is rancidity. Second effect, rancidity. Now what is rancidity? So our food items, many food items there which we do not use or eat regularly. Sometimes we keep them for future use, like pickles, like chips, anything which are packed food items. So in case of packed food items, what happens there? There occurs oxidation with the molecules present in the food items. So after the oxidation of the molecules present in the food items, the taste of the food changes. The taste of the food changes, and this phenomenon is known as rancidity. And the taste changes and the food becomes rancid. Food becomes rancid and the phenomenon is rancidity. Okay, so we don't want this type of oxidation. To prevent this type of oxidation, we use antioxidants. We add antioxidants. Anti means against. Anti means against. Oxidants means which are related to oxidation. So these are against oxidation. They prevent oxidation. They do not allow oxidation. So in this way, food items is preserved. So with this, the chapter finishes. In the next video, we will start with a new chapter from physics part from class 10 science textbook. Okay, then thank you very much for your valuable time. Okay, see you. Bye bye.